Hi, everyone. My name is Sunny Aggarwal, and today I will be giving a presentation called Many Chains, Many Tokens, One Ecosystem. So a bit about me, I'm a researcher with Tendermint Cosmos, and my particular interests are focused on proof of stake as well as blockchain interoperability. I've one of the co-founders of the Blockchain at Berkeley organization, and have previously worked at Consensus. And I absolutely love Switzerland. I am teaching a class at Berkeley this semester on Switzerland, so I'm so happy to be here. So the two products that Tendermint works on are mainly Tendermint, the consensus engine, as well as Cosmos, an Internet of blockchains. So why do we call ourselves the Internet of blockchains? The Internet is basically a huge network for connecting people who are using different applications, different infrastructures, but it's creating an inter-network, a way of connecting many different infrastructures together. So throughout the presentation, I might have a few slides that have a white background. This is from a class that I'm auditing this semester at Berkeley. And I think it actually relates pretty well about the traditional internet to the internet of blockchains. So what was the goals of the original internet? Basically, the idea was we wanted to connect many different networks together and have the ability to scale to the entire world, as well as tolerate and recover from failures. So the third one is basically what blockchains do, but we need to achieve those first two goals still. So what are some of the big issues that are facing blockchains today? We want, obviously the main one that everyone's up in arms about is scalability. But there are other ones as well, such as privacy, sovereignty, security, diversity of blockchains. So we'll go ahead and talk about how Cosmos and Tendermint create this Internet of blockchains that achieves these goals. So first off, the first goal that we have is scalability. You have two different kinds of scalability, which you have vertical and horizontal scalability. Vertical scalability is achieved through many different systems, such as like proof of stake, state channels. Tezos announced that they're looking into recursive snarks. This is basically the idea of having one chain scale very heavily. Then there's also horizontal scalability, which is the idea of interoperating many chains that can scale the ecosystem as a whole. So for example, if one blockchain can have X throughput, how do you get 10X throughput? You just make 10 blockchains and have them all talk to each other. It's easy as that. So what Cosmos tries to do is achieve this kind of scalability, this horizontal scalability. Tendermint works on the vertical scalability with its fast proof of stake with like 1 to 3 second block times, over 1,000 transactions per second. But Cosmos works on the horizontal side of things. So you may have heard of horizontal scalability through different names. Ethereum calls it sharding. Basically the idea, it's all the same, splitting into many chains. Ethereum sharding, however, focuses more on address space sharding, which is, each contract has an address, and so each shard has like all the contract with like in a certain address space. But the thing is, that's not really, in my opinion, the most logical way of sharding. In my opinion, the most logical way of sharding is application-based sharding. You have one dApp, and most transactions that are happening in this application are with other users of that application. So if you shard by application, most of the things that will be transactions in this application will be staying in the shard, and very rarely do you have to do cross-shard communication, which is the bottleneck. And the cool thing about this is if you have application-based sharding, you only have to be a node for the applications you care about. Let's say you're a Golem user, right? Why do you have to, process all the Storj transactions and all the Sia transactions and everything else? You just care about the application that you're using. So you should only be a node or like client for the blockchains that deal with those applications. So now that we have this idea of application-specific chains, I'm going to make a pretty radical proposition that I think that Turing-complete VMs are actually not that great of an idea. And I like the system that was happening in the ecosystem before Ethereum came along and pushed this very Turing-complete VM mindset. Basically, Turing-complete VMs are great for prototyping. And they have I think some use cases are good for Turing completeness, such as like TrueBit and stuff like that. But I think most production dApps actually don't need to be on a Turing complete chain. Let me give you an example, right? Golem, if it's on its own chain, what do you need? You basically need two main things. You need a marketplace, and then you need a computation verifier, let's say TrueBit in this example, right? So what you can do is you can just build a chain that has those two functionalities and nothing else, and you deploy it. And it does its one purpose. And if you ever need to, you can have some flexibility and you can do improvements through governance. Like, you just hard fork and add more functionality. 2 years down the road, you say, hey, we want to do ZK snark verification as well for Golem. So you can just add that in as a new module, as a plug-and-play blockchain, which Cosmos SDK allows. And you can update the system. And so what is the benefit of not having this Turing completeness? You get to massively reduce the attack surface. You get to avoid bugs like the DAO bug if you don't want to use Oyente. You also get a lot of efficiency gains due to less computational overhead. Let's say your blockchain is just a basic key value store. You're just storing like the hash of a data in it, right? As in like Melon Mail, for example. You don't need all that computational overhead of running an entire Turing complete VM for that. And in a proof of stake system, all the computational overhead, all the overhead and latency is due to either network latencies or computational overhead. So if we get rid of this Turing complete VM, we can actually reduce the overhead and make it much faster. And then finally, you can fine tune for your application. For example, UTXOs tend to be a very good payment processor, which is why Bitcoin went with the UTXO model. But accounts are better for general purpose computing. But if you want to make a blockchain that's only like a payment processor, you shouldn't have to go with the account model. You should be able to go with something like the UTXO model, which optimizes for your use case. So, okay, great. If we have all these application blockchains, they're much more secure because they're not Turing complete. But now the one cool thing that Ethereum did give was this interoperability, right? You had different applications can talk to different applications. You can use Uport with a bunch of different dApps. You can use 0x with a bunch of different dApps. But just because chains are separate doesn't mean they don't have to talk to each other. You can use a protocol that we've created called IBC, and it stands for Inter-Blockchain Communication. But basically what it is it's a two-way on-chain light client protocol. Basically what that means is you should be able to prove things about one chain on another chain. So what you can do here now is that means applications and smart contracts on different chains can interact with each other, send tokens back and forth, send data back and forth. And the Cosmos Hub allows for this like deep integration of token economies. And what I mean by deep integration is you can not only do like token swaps and exchanges, you can do actual token transfers. So let me give you an example. Let's say you have two blockchains, Ethereum and Ethereum Classic. On Ethereum Classic, what you can do is you'll have a smart contract where what you do is you send your Ethereum Classic to it. It freezes the Ethereum Classic on that chain. You submit proof of that to a smart contract on the Ethereum chain, and it gives you an ERC20 token that represents one Ethereum Classic. And what you can do is you can spend that on the Ethereum blockchain, and once you're done, you can actually you can refreeze it, the ERC20 on Ethereum, and then submit proof of that to the Classic chain, and then withdraw it on the Classic chain as if it never moved. And so the cool thing about this is token exchanges and swaps, they don't actually let value move because the nature of a trade is that two things of equal value have to be swapping. So value didn't actually move across chains. Meanwhile, with a token transfer, you actually can move value between blockchains. So yeah, one of the other goals of the internet was you wanted to basically connect different competing entities. So one of the important things when we want interoperability is we want chains to be able to maintain their sovereignty. Basically, fundamentally, Ethereum and Ethereum Classic should not have the same validator set, right? They have fundamentally different philosophies, and they need to remain separate for some obvious reasons. So with the Cosmos Hub, we allow different chains with different validator sets to still talk to each other and interoperate. And what this also allows, which is really cool, is that means that private chains can interoperate with public chains. You can send data from a private chain to a public chain. You can send tokens from a public chain to a private chain, and then back to public. And then also another cool thing about sovereignty is you can use community power to achieve greater security than pure economic incentives alone. For example, one of the projects I'm somewhat involved with is a project of a country called Liberland. And I don't know if any of you have heard of it, but yeah. But one of the cool things is that if you do a proof of stake using Liberland's currency, right, the people who are involved in this project have greater incentives than just economic alone. They have ideological and political and social incentives to protect the network. It's much harder to, you know, the bribing attacker model and stuff. It's much harder to bribe someone who's not just in it for the economic reasons, but they're actually in it for something else as well. And so these sovereign blockchains help you achieve that. As well as you get governance controlled by the community. For example, when the DAO bug happened, the Ethereum community is very small. A lot of people were very invested in the DAO, so it was easy to convince everyone to roll back. But now, when the parity multisig bug happened, 3 projects got completely screwed by this bug, while everyone else was essentially ended up being okay. And these 3 projects didn't have the ability to roll back the chain to solve it because they didn't have control of the chain. They would have had to convince the entire Ethereum community to do that. And so if you have like application-specific chains, your application's community has control over governance. And then some security stuff is, you can, these different blockchains, you can merge their security using like merge mining in the case of proof of work, or basically delegated consensus in the case of proof of stake. Don't want to go too much into that. Then we want diversity. We want applications to be able to be built with a multiple of different implementations and clients. Bugs happen in clients. And so we want to be able to resolve for these. And so to plug into the Cosmos ecosystem, you can build it using Tendermint ABCI apps or Cosmos SDK apps. These are some cool development frameworks that we have at Tendermint, which I can discuss with anyone afterwards who's interested. But yeah, basically we have, like, for ABCI, we have implementations in many different languages. Those are just a few of them. And one of the cool things about ABCI is you can connect it to on existing software. For example, we took Geth and basically stripped out mining and put it on Tendermint consensus, and we created a project called Ethermint, which is, basically pure proof of stake Ethereum, and with about 1 to 3 second block times, over 500 transactions per second. We have a testnet running. You can go run true proof of stake Ethereum right now. Or, for example, someone for our hackathon took Chain's VM, chain.com, and it's a private blockchain platform, and they basically turned it into a public blockchain platform by taking out the private part and putting it on Tendermint consensus, and that's called Chainmint. And we can also connect to existing blockchains as well through something called pegged bridge zones. Last month in Shanghai, our team had a long conversation with Vitalik about collaborating to connect Ethereum, the normal true Ethereum chain, into the Cosmos Hub. So, okay, what are all these benefits? What we've basically done is created this one ecosystem of many different blockchains and many different tokens. So some of the cool things that we can do now with this is the features of different existing chains can be interoperated. You can use the benefits of Bitcoin, along with the benefits of Ethereum, along with the benefits of Zcash, and basically all these platforms can actually, benefit from each other's developments. Bitcoin, you can move you can move Bitcoin onto Ethereum and use the new ZK snark capabilities of Ethereum to make anonymous Bitcoin transactions. Like, that's really cool. And for example, Bitcoin today is basically sort of the best known payment processor in the blockchain space. Like, I don't know if it's the most optimal, like, technically, but it's definitely the most well known, while Ethereum is known for its smart contracting capabilities. So using these like token transfer capabilities, we have the ability to do Bitcoin transfers through Ethereum smart contracts. You can get the best of both worlds in one system. And what this concept of using tokens that don't have to be contained to specific chains, but are rather on many chains. You can have one application that has a smart contract on both Ethereum, Tezos, and Rootstock, and use the same token across all of them, because these tokens are transferable between these chains. And so this is one option of what can happen if this sort of this multi-chain token system works. The other option is something like Bitcoin becomes king again, where personally, just a heads up, I'm a Bitcoin currency maximalist. While I hate the Bitcoin protocol, I love the currency just because I think it has the most widespread adoption right now. And so the cool thing with this would be that Bitcoin can be the multi-chain currency once again, where you can move the Bitcoin blockchain will basically just be used as a proof of work mint, where you mint Bitcoin, and then it'll just be moved off into different blockchains from there and be used to spend in Ethereum smart contracts or Tezos smart contracts and all sorts of things. So another cool thing is that you can have smart contracts call contracts on other chains. You can have a smart a Cosmos SDK smart contract call something on Tezos, which calls something on Ivy, which calls something on Ethermint, which then sends the result of all that data back to the Cosmos SDK. And you can have these like different implementations all talking to each other. Private chains can now interoperate with public chains. One thing when it comes to decentralized exchanges, one thing I'd like to bring up is like, a lot of decentralized exchanges like EtherDelta, for example, are focused on the Ethereum ecosystem. But if we actually take a look at all the the top market caps of different tokens, none of the top 10 are actually ERC20s on Ethereum. Let's go on to the next 10. Okay, Amis Go is number 13, which is an ERC20 right now, but that's only because of its crowd sale, and the intention of that is to move on to a different system at some point. Okay, where's our first ERC20? We finally reached our first ERC20 at number 28 with Augur, right? That's the first actual ERC20 that's on the system. And so if we're building a decentralized exchange, we can't be limiting ourselves to just the Ethereum ecosystem, right? We have to be looking bigger than just that, and that's why like companies like Kyber and Amis Go have already been like are working on like building with the Cosmos ecosystem as well. And one final question, something to ponder that I just thought of a few days ago was, will this lead to geographic sharding? With one of the things with proof of stake is that most of the overhead is through network latencies, and you're limited by the speed of light and all that stuff. So if you have like chains that are like regional chains, and then these regional chains like talk to each other, how does this affect our view of decentralization and whatnot? So this is just another interesting question to keep in mind when thinking of these. And so just one thing I'd like to, it's called the Internet of Blockchains. David Clark, who was an early internet pioneer, he had this quote where, "We reject kings, presidents, and voting. We believe in rough consensus and running code." And so I think that, blockchain helped finally bring this idea of rough consensus and like dictating the future of the system. And so now we can create the Internet of Blockchains, where you have many different chains all interoperating with each other and creating one massive Internet of Blockchains. So thank you. I don't know if I have any time for questions. I do not have time for questions.
Thank you very much, Sonny. It is my great pleasure now to announce Andrew Keys, who many of you know from Consensus, but is also now the main driver behind Consensus Capital. So look forward to hearing your talk, Andrew.